按下去，那这样就开始录了。然后待会如果有休息时间，就可以按暂停。那如果没有休息时间，就直接按
不要了，我
停，
直接把它弄完。
直接弄完，那就是就是录完之后就按这一颗就停止了，就这一颗红色方形，
这颗停止。
对，这一颗是停止。
好 ，OK， 好，可以了。
对。
OK， 谢谢。Good afternoon, everybody. So,
Good afternoon, sir.
let me check your attendance. Okay. The first one will be Anupriya. Is that here?
No, Professor.
No.
Yeah.
The second one is Shabana.
She's also no, Professor.
Not here.
No.
The third one is Naveen.
No,
Not
Professor.
here. Okay, we wait for a while. I think somebody just
Yeah. Somebody just joined, Professor.
yeah. So 1, 2, 3, 4, 5, 6, 7. So 7 people comes, 8 people comes. So how about from the back, the Evangeline? Is that here?
Yes, Professor.
Yes? Okay. Vasentin, is that here? Not here. Okay. 1, 2, 3. Oh, Shabana here. Okay, good. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We got to have 11 students. So far, we have 8 students on the line. Okay. We still wait for 3 more. Okay, thank you. I think probably the whole people come. Okay, let me check with the list. Okay, Anupriya, is that here? Anupriya. Yeah, I think you need to open your microphone to say yes. Okay, Anupriya. I saw your picture. Okay. Shabana, are you here? Yeah, I think I saw your picture. Must be here. Yes, I saw. Naveen.
Yes, Professor.
Yes,
Yes.
good. Janisha, are you here?
Yeah.
Yes, good. Kursika, are you here?
Yes, Professor.
Good.
Yes, Professor.
Kumar,
Yes, Professor.
good. Srinisi, I don't know. I pronounce this Sprinisi. Sorry, Srinisi. Are you here? Ruspika.
Yes, Professor.
Okay, good. Oh, Srinisi. Yeah, I saw you. Good. Kumar Gurabarn. Kumar. How to pronounce this?
Yes, Kumara Gurubaran, Professor. Yes, Professor, I'm here.
Give you a short name. How to say your name? Is that Kumar?
Kumara Gurubaran.
But we have 2 Kumar, so you are the second Kumar.
Guru.
Okay, is that okay? Second Kumar. Okay.
Yes, okay, Professor.
Vasentan.
Yes,
Okay.
Professor.
Yeah. Vasentan.
Yes, Professor.
Vasent. Vicens. You are Vicens, not Vicentum. Vicens. Okay. Okay. I think you all here. So we start from based on your student number. Anupriya will be first, Shobana will be second, Naveen third, so and etc. and etc. So each person should present your work just less than 5 minutes, and I will give you a question. Then you just sit on the line of watching the second one. Is that okay? Okay, Anupriya, you go first, please.
It's audible for you?
Yeah, that's your turn. You go first. Share your screen. Yeah. Share your PowerPoint. Yeah. Go ahead. Anupriya, I cannot see any of your. Yes. Yes. Go ahead. Yes.
Good afternoon to all. Today I am going to present the topic is development of molecularly imprinted conducting polymer specifically based electrochemical sensor to the melamine reaction implant structure of the work. First prepared for aniline with acrylic acid electrochemical process to form MIP complex. In that form, a complex was confirmed by CVFTISM analysis. In electrochemical studies were achieved at 0.1 to 180 nanomole linear range and the LOD was 0.0573 nanomole to 0.0172 nanomole. And finally, the sensitivity depends upon the synergistic effect between electrostatic interaction between
Anupriya, you please. The communication is not very clear, so please speak a little bit slower. Okay. Go ahead.
Okay, Professor. Then the real sample analysis were carried out in milk sample. Then introduction. Melamine is one of the 135 triazine unit and 246 triamine unit. It is a very weak base, non-edible, non-hygroscopic and white crystalline nature. Its melting point and the decomposition point is very high at 347 degrees Celsius. It is very slightly soluble in water and it will contain more nitrogens. So, but in this melamine contaminates, it's previously recorded. It very affect for our kidney stone formation. So we need to detect if melamine is very important. Here, melamine detection by using molecularly imprinted conducting polymer. First of all, molecular imprinted polymer technique is one of the polymerization with a functional monomer. Here, monomer was polyacrylic acid and the cross linker around the template molecule form the apple polymerization process. This molecularly imprinted conducting polymer was formed from MIP electro-optical properties of polyaniline with easy deposition and conducting polymer. Here, the chemical sensor change when it rebinds the template and generate relationship between the concentration of template molecule. This is measured in polyaniline exhibit the high electrical conductivity, current potential and conducting capacitance and very specific selectivity from the occurrence effect. Polyaniline Polyaniline was one of the conducting polymer. Its special properties of high electrical conductivity, excellent electronic optical properties. So, these are the properties. So, we need to use polyaniline here. Acrylic acid is one of the common hydrogen donor and acceptor monomer. Here to prepare polyaniline with polyacrylic acid complex. Sensing material modification with organic acid like acrylic acid, increasing the binding size since the carboxyl group activates a hydrogen bond donor acceptor simultaneously. Okay, finally, the aim of the work was aniline and acrylic acid is a synergistic effect interaction between aniline contained in H2 and acrylic acid COOH group to increase the sensitivity. Finally, the aim of the work was to develop a aniline with polyaniline with polyacrylic acid to used for detect melanin sensor, the electropolymerization process. Synthesis of melamine, polyaniline, and polyacrylic acid. Here to see 0.2 mole of polyaniline and 0.2 mole of acrylic acid in the presence of 0.01 mole of melamine at the electropolymerization process under a sweeping potential carried out in 0.2 to 1.0 volt. Scan rate was formed at 100 MV per second, 10 cycles to form MACAA polyacrylic acid GCE oxide. In that conducting polymer was confirmed by FTIR analysis. This black one is polyaniline. Here to exhibit 3338 is a NH stretching vibration and 1635 is a CN stretching vibration. Second one is aniline with acrylic acid. Here to form 1300 centimeter minus 1 is a CH NH stretching vibration and this 1638 is a C double bond stretching vibration. The third one of the MIP. Here to form 3300 4 was a NH stretching vibration. 1634 is a C double bond stretching vibration. 1045 and 1016 is a
Time is almost close, so show me the result of the conductivity. Is that okay? Conductivity, yeah. And the brittle or not, yeah. Conductivity, do you have conductivity result?
Yeah.
Not SEM, yeah, yeah. Yeah, currents, yeah, okay.
CV were carried out here to this is for non-imprinted melamine to see very low conducting. This is melamine composite to form high conducting. So this is ferric cyanide system had carried out similar to this blue line is a molecularly imprinted here to see high current. LOD and LOD sensitivity, specificity, selectivity were carried out in DPG analysis here to achieve imprinted polymer to exhibit.
Okay. I think the time is close. Can you tell me you use this sensor for censoring what kind of material? What kind of material for censoring? Anipria? What kind of material for the sensor?
To detect melamine, Professor.
You will detect what kind of material? The censoring, yeah, melamine. You want to determine melamine?
Yeah, yes, Professor.
Because it's caused a milk problem. Okay, you want to detect the melamine by the Nippon. Okay, good enough. Okay.
Thank you.
Thank you.
Thank you,
The
Professor.
second one, Shobana.
Yes, Professor.
Yeah, go ahead. Can you enlarge your screen? I see a little bit smaller
Yeah,
and
I will.
okay. Yes, go ahead. Present the most important work, okay?
Yes,
Go
Professor.
ahead, go ahead. Yeah.
I'm gonna present a work of application of conducting polymer composites to a electrochemical sensor. It's a review paper. So, the organic pi-conjugated polymers, which are formed by electrooxidation method called conductive polymers, those are having a properties like lightweight, lightweight workability, resistance to corrosion, and low cost, easy to synthesize, and suitable matrices for a biomolecule immobilization have enabled them to find a wide range of use. And they all plays a major role in supercapacitors, batteries, electrochromic devices, solar cells, sensors, and biomedical applications. To enhance the performance of the conductive polymers, various composites materials have been synthesized with the carbon-based materials, metal and metal oxides, and also enzymes and others also. This article reviewed the conductive polymers and their composites, followed by their applications, especially the electrochemical sensors that are based on conductive polymers and their composites, and to address the future aspects to electrochemical sensing materials were summarized. So the conducting polymers, which having a high electron affinity and redox activity, and they're having a physical property such as a size and length, which is expressed in the terms of a molecular weight, and the chemical properties such as a polymer chain and their solubility. So these conducting polymers are prepared by oxidizing the monomer of their the polymers using oxidizing agents or applying a potential or current via electrodes. The conducting polymers composites prepared from highly conductive nanomaterials helps to improve the functions and also enhances the physical and chemical properties. So the composite materials which having a composite with the conductive polymers, if we have a carbon-based materials for excellent conductivity, high thermal stability, and having a large surface area such as a carbon nanotubes, graphene, carbon dots, and porous carbon are used to composite with the conductive polymers. Metal and metal oxides such as a platinum, palladium, nickel, copper, and TiO2, MnO2, zinc oxide, and Fe3O4, having a biomedical used in applications such as biomedical research, optoelectronics, catalysis, and sustainable energy, and also electrochemical devices. So the biological active materials such as enzymes, DNA, proteins, antibodies, and antigens, or these types of conducting polymers, conducting polymers which having a composite materials does not change the properties of biomolecules. So the application to electrochemical sensor, electrochemical sensor converts the chemical reactions of the target species on electrodes into electrical signals that exhibited changes in current, potential, and conductivity. So these are the conductive polymers: polyaniline, polydiaminonaphthalene, polypyrrole, polythiophene, and polytetiophene. The composites which having going to apply the sensor electrochemical sensor application, especially The polytethiophyne and composites are going to work as a sensor application because this is another class of conducting polymers, and their unique properties have allowed them to perform excellently when compared to other conducting polymers. Polytethiophyne and their composites are such as electropolymerization of tethiophyne with the carboxylic acid, that is a TTCA monomers on a glassy carbon electrode for used to detect the DNA hybridization in a portable DNA sensor. So this poly-TTCA was also developed to detect the DNA and proteins by covalently functionalizing hydrogen on the surface. The composite of diamino tithiophyne, that is a DATT polymer, and EDTA used the composite is used to detect the detection of a heavy metal ion sensor, and also is tested as a biomimetic membranes and to detect superoxide in vivo using microbiosensor. So the DATT also used to detect heavy metal ions was developed and employed as disposable sensor that had been modified with the geo-doped composites. So covalently bonded cytochrome C to a conductive polymer layer was used in bioelectronic devices to determine the presence of nitric acid and NADH. So the benzoic acid group, which is bearing with the tethiophyne, it's a TTBA, that's a tethiophyne benzoic acid, was synthesized and used to in various biosensors, such as and also a chemosensors, including those that detect the glucose, H2O2, phthalates, esters, and cancer cells also. The new functionalized tethiophyne monomer, which is a
Okay,
composite of the
good. Shabana,
yes, professor.
this paper is a review paper, right? So
Yes, professor.
they don't have a specific test. They just go
Yeah.
over for the review. Okay, I just ask you one question. You say
Yes,
the
professor.
polytersiophyne looks very
Yes,
promising to compare with polyaniline or other conductive polymer. Do you have any
yes,
specifications reason for that? Do you have any special reason for that? Okay, polytersioph.
because
Yeah. Do you know my
because
question?
polytetrahydrine
Yeah.
is comparatively the other polymers, it's having a high stability and a high electrical conductivity. This all the reports were reported by the author in this paper, professor.
High electric conductivity. Are you sure? So it's a
Uh,
conjugate polymer, right? It's a
yes, professor.
conjugate polymer. So higher conductivity. Okay. So do you work on that right now or just for the paper review? Do you
I
really
didn't work on this, professor.
you didn't work
I
on
didn't
this
work on
this field, sensor field? Okay. Okay, good.
it.
Okay, good. Okay, Shabana, it's okay. Good enough. Next
Thank you.
one is Naveen. Naveen?
There is
Yes,
professor.
go ahead.
Okay, professor. Is it okay, professor?
No, I cannot see your PowerPoint. You need to share your screen.
Oh, okay, professor.
Yes? Looks yes, good, good. Go ahead. Yes.
Okay, professor. Okay, professor.
Yeah.
Good evening, everyone. Today I'm going to present a paper on electroactive triphenylamine-based polymer films as a passive ation layer for improving electrochemical oxidation stability of silver nanowire. Before, the pristine silver nanowire has several advantages such as tunable figures of merit, large-scale processability, and flexibility, and it has such a disadvantages like instability under thermal condition, mechanical stimuli, particular sustained electrical currents. In order to overcome this disadvantages. They fabricated a passivation layer over the silver nanowire. After the passivation layer has applied over the silver nanowire, it enhanced the electrical stability, excellent redox activity, and optoelectronic properties. Electrochemical stability over continuous 50 oxidation redox cycles, excellent oxidation stability for continuous 300 switching cycles and optoelectronic behaviors, and very successful ideology for the stability of various next generation application by replacing the rigid glass substrates with other flexible or even stretchable substrates. This is the DPV performance with the pristine silver nanowire. At the first scan, we can clearly see the oxidation peak observed at 0.7 potential. At the very second scan, there is no oxidation peak is observed. This is the major disadvantage of using a pristine silver nanowire, which is easy oxidation and weak adhesion, poor stability under the conduction current. The pristine silver nanowire electrodes easily resulted in oxidation and corrosion of silver under positive potential in any electrolyte solution. This is the major disadvantage of using silver nanowire. That is the reason for the research group to fabricate a passive layer over the silver nanowire. This electrochemical property. After the fabrication of triphenyl polyamide passive layer over the silver nanowire, this CV performance clearly we can see the oxidation peak which is observed at two oxidation peaks were observed at 0.76 and 1.06 potential. Next, the DPV performance also shown the two oxidation peak. One is at 0.62 and another is at 0.91, which clearly shows the improving thermal stability, transparency, and the mechanical flexibility of a silver nanowire, which reflecting the most favorable kinetic process. This is the different scan rate in order to know the rate transfer, electron rate transfer kinetics. After increasing this scan rate from 10 millivolt per second to 350 millivolt per second, the current cathodic and anodic peak current linearly increased, which suggests the electron transfer process is a diffusion controlled process. The next one is spectroelectrochemical properties. After the passivation layer over the silver nanowire, first they performed until the 0.8 voltage. There is a change in the passivation layer from white color to green color. After the potential changing from plus 1.1, then the green color is changed to the blue color. We observed with the spectrochemical property with the absorption spectrum. Then the cyclic stability test. They performed up to 50 scan. After the 50 scan, there is a slight change in the oxidation and the anodic and cathodic peak current. From this, we can clearly observe the ability of the passivation layer. This is optical and electrochemical properties of electrochromic device based on silver nanowire triphenyl polyamine hybrid electrode. They are using heptyl viologen was used to fabricate ECD with an ambibipolar system. Here also two oxidation peak were observed in CV and also DPV. Here the ECD performance shows that the absorption peak observed at 603 and 605 is attributed to the heptyl viologen oxidation stage. Then for the TPPA polyamide film observed at 357 and 993 are observed for the first oxidation stage, and the two peaks are observed at 371 and 944 corresponds to the changes from green color to the blue color. Then the cyclic after the passivation layer, they perform this cyclic stability test. After 300 scan, it shows the greater stability. There is a slight change in the anodic and cathodic peak current. After the passivation layer, they perform the good stability over the
Okay,
silicon.
okay, good enough.
silver
Can
nanowire.
you can you explain one more time why
Okay.
you add the silver nanowire with what kind of material? It will change the color. The color meaning is oxidation reaction. Is
Professor.
that right?
Yes, yes. They use the heptyl
So
violet.
can you explain why the color will change? Why the color will change? To change based on the Ag nanowire will be the
Yes,
same
Professor.
or it will be oxidized?
Yes, Professor. And the first stage, the silver is oxidized, Professor. The very first stage.
So what's the TPPA mean?
Triphenyl polyamine, Professor.
So it will censoring
It acts
what
as
kind of material? It will censor the metal
no,
or what
Professor.
kind of material? Biomaterial.
No, it's not sensor, Professor. They use the passivation layer to enhance the stability of silver nanowire, Professor.
Or to
Here they
enhance the
perform.
stability.
Yeah. Instead of they performing with a only with the silver nano layer, at the very second performance, the no oxidation peak is observed, Professor. So only they use the.
Wait. Go next page. Next page. Okay,
Okay,
so
Professor.
this kind of compound is TPAA. Is that what kind of the right hand side compound is a TPPA?
Yeah.
It's a polymer with a silver nanowire. Why its color will change? Can you explain this?
This one, Professor, right?
Yes.
Professor, here they are using uh, because of change in oxidation state, Professor.
Changing the oxidations.
Yeah.
So
Because of oxidation.
which material will be changed? The TPPA?
Yeah, yes. TPPA changes into TPPA radical, Professor.
Okay, so that's why its color get changed, right?
Yeah, yes, Professor.
Okay. A potential so color change. Okay.
Yes, Professor. From
I know the application. Okay, thank you, Naveen. Okay,
thank you.
Janisha, you are next one. Janisha?
Yes, Professor.
Yes, go ahead.
Is my screen visible, Professor?
So far, yes, good enough. Yeah, you can go ahead to report.
Okay, Professor. Okay, this is the paper that I've chosen. This is mechanical properties and extended creep behavior of bamboo fiber reinforced recycled polylactic composite using the time temperature superposition principle. So, the main objective of this paper is to synthesis a mechanically strong and creep resistive composite, which is actually made from bamboo fibers reinforced polylactic acid. And they had studied its properties in various fiber loading levels, and they had reported its flexural properties and creep resistance. So, to understand some of the basic properties like density, moisture content, and static flexural properties, this table is summarized. So, here we could see the composite with different loading amounts ranging from 0, 5 to 80 weight percentage. On observing the density of these different composites, we could see that the density of composite with 80 weight percentage of bamboo fiber shows the lowest density. This is because of the compression in the molding process, in the preparation process. The thickness would have increased because of some swelling in the mold. And then the second one is the moisture content. So there is a uniform trend followed in all these composites. That is, the moisture content increase with increase in the weight percentage. That is, from 0 to 80, the moisture content increases. This is because on increasing the weight percentage of bamboo fiber, uh, the bamboo fiber is capable of trapping the atmospheric moisture because of its cell wall nature. The cell wall is hydrophilic in nature, therefore, it is capable of trapping moisture and increases the moisture content. Obviously, the density and the moisture content of this uh, composites affect the flexural properties. The flexural properties, mainly the modulus of rupture and the modulus of elasticity, follows the same trend. That is, on increasing the loading amount from 0 to 60, the property get increases, and on further increasing to 70 or 80 weight percentage, the properties decreases. This would be accounted in the future slides. So here is the dynamic mechanical properties of the composites. So here we have uh, the um, the storage modulus plotted against the tan delta, which is the function of fiber loading level. So here we could see that the TG is for polylactic acid, the TG is at 50 degrees Celsius. In this composite, we could observe that the E prime dropped to a lower level at 98 degrees Celsius, and it got then increased at 120 degrees Celsius. This is because the drop is mainly because of the amorphous nature of the polymer, and the increase in the 120 degrees Celsius is because when the polymer is persistent to temperature, then it undergoes annealing and it forms some crystallite structures, and thus there is some increase in the TG at 120 degrees Celsius. Sorry, E prime in 120 degrees Celsius. Also, in the second figure, we could see that we could see that the different loadings, that is from 0 to 80, is plotted. So here we could say that from in 98 and 135 degree temperatures, we could see peaks. These peaks also represents the amorphous and the crystallite structure. And another trend that we had
Janisha,
seen
you need to accelerate your presentation, okay? Go ahead, go ahead. Yeah, accelerate.
um,
Yeah.
Okay, Professor. Even in this, we could see the trend that we followed in the previous table. That is, till till the amount 60 weight percentage, the characteristic feature increases, and then in 1780 it decreases. And this is the extended creep behavior observed. So the figure 2a shows the creep compliance with elevated temperature in the actual time for the entire duration, and the B shows the unshifted and shifted short-term creep compliance curves of the composite with weight percentage 60 at temperature tested plot against the log of time. So according to this, we could calculate the shift factor based on two formulas. One is the WLF equation, another one is the Arrhenius equation. We cannot use WLF equation here because it's during 60 degrees Celsius to 160 degrees Celsius, it undergoes rubbery state transformation. Therefore, we use Arrhenius plot to identify.
Okay, good. Janisha,
Okay,
time is
and then
close. No, go to the conclusions. Let me read the conclusion. Yeah, yeah, go ahead. Yeah, explain that.
So here in this entire article, they had synthesized the bamboo fibers filled in the polymer matrix polylactic acid, and they had observed the creep resistance properties and the storage modulus of the composite. That's all.
Yeah, good. I think let me ask you one question. They use PLA, right? Polylactic acid. Do you know it's a biodegradable polymer? Do you know?
Yes, yes, Professor.
Yes, good.
Yes.
So if they add bamboo fiber inside, do they say it will accelerate the biodegradability or they didn't do the test?
They didn't do the test, but of course, using a bamboo fiber is actually to increase the biodegradability. Instead of using any synthetic fibers or synthetic polymers,
Yes,
bamboo fiber
okay.
would be natural.
But the bamboo fiber, do they really dry out to eliminate their water, or they didn't do that? They just go straight to put into the PLA. When they prepare the sample, what do they do?
Um, Actually, they don't dry out the sample, Professor.
They didn't dry out the sample. Okay,
Yeah,
okay. Mhm.
there is moisture content in it.
Yeah, moisture content will be very harmful for this composite. Okay. Okay, good enough. Very good. Janisha, you search the material is related to our class. So your work will be any on this field, or that's just for your paper review?
No, it is just for the paper review, Professor.
Good. You good job. Okay, thank you.
Thank you.
So the fifth one is Kursika. Please.
Yes, Professor.
Yes, go ahead.
It's my screen visible, Professor?
So far, no, I didn't see your screen. I didn't see your PowerPoint so far. So I don't know what's going on. Can you handle that?
No, Professor. Wait.
How about that? Yeah. I got your screen. Yeah, good enough. Yeah.
Shit.
Yeah, good. Yeah, go ahead.
Okay. Okay. Good afternoon, one and all. Gathered here.
Yeah, I
Myself,
can read that. Good. Go ahead.
okay. Myself, Kirtika Devi Ramadas. This is the article I have chosen for my presentation. The article is and title is Novel Electrochemical Sensing Platform based on molecularly imprinted polymer decorator 3D nanoporous nickel collection for ultra sensitive and sensitive determination of a metronidazole. Here the author have chosen the drug is the metronidazole as the target analyte for the electrochemical investigation. Metronidazole is an antibiotic drug. It has been widely used. However, if the concentration of the drug is increased, the prescribable level is caused the stomach upset and head pain, dizziness, and vomiting. Therefore, the detection and quantification of the drug is the highly required one. Abstract of this the paper. The novel electrochemical sensor has been developed by the using the composite element of the three-dimensional nanoporous nickel and molecularly imprinted the polymer. The nanoporous nickel is introduced in the order to the increase the electron transport ability and the surface area of the sensor. while the electrosynthesis is the molecular imprinted polymer layer of the simultaneous identification and quantification of the target molecule. By using the metronidazole as model analyte, the sensor based on the composite hybrid with the great filters is the remarkable low detection limit of the 0.2 femtomole, super selective in discriminating the metronidazole from is the structural analysis is a good anti-interference ability towards serial coexist the substance. The composite sorry, the composite presence feature with the admirable merits makes it the promising candidate for the developing the electrochemical sensor devising and the place the low in the world in the field. Molecularly imprinted the polymer. This the polymer that has been processed using the molecular imprinting the technique, which leaves the cavity in the polymer matrix within the affinity of the chosen template molecule. The process usually involves the initiating the polymerization of the monomers in the presence of the template molecules, that is the extractor after leaving beginning the complementary cavities. This the polymer have the affinity of the or- original molecules and has been used in the application such as the chemical separation catalyst or the molecular sensor. Preparation the method. Initially, copper and nickel were electrochemical deposition. Then the copper alone the removed from the electrode surface, which make with the cavity. Then the electropolymerization was performed along with the drug metronidazole. Here, the author have used the orthophenylamine in this polymer. During the electropolymerization, amine group is the lost. The one is the electron is from the cation radiation radical is the further reaction with the another unit of the orthophenylamine and form is the dimer. This reaction is continuously takes the place and form the polymer. After this, the electroposition, the drug alone the extract from the electrode surface, which makes the imprinted over the electrode surface. It was used as the working electrode. Result and discussion. Figure 2a and B is shows the FESM's image of the copper nickel alloy. It's exhibited the stall like the structure. When the deposition copper is the removed, is the crater the cavity and it's shows in the figure 2b. Figure 2c and D shows the before after extraction of the electro deposition metronidazole. In the presence of the metronidazole, the nickel balls get the thickness, while the drug was extracted from the electrode surface is make the nickel balls become the thicker. The EDX spectrum clearly shows the decreased the intensity after remove of the copper from the electrode. The indicating the successfully remove of the copper from the surface. It's a evidence of the efficient result also. Electrochemical studies. The electrochemical behavior of the fabricated electrode are examined using the cyclic voltammeter technique in the Profis solution. Figure 3a, each color respector and electrochemical response of the each modification. Here the red color curve shows the response of the non-operous nickel GC, which shows the high peak current response, indicating the non-operous nickel plays on the important role in case of the sensor signal. But when the non-porous nickel GC was the covered with the polyaminophenol film containing the metronidazole, is the signification reduce the current response. It's a source in the green color response. The decrease in the response is due to the fact that the non-conductivity nature of the polymer. Moreover, the polymer film fully covered the electrode surface. Is there was no channel for the active prophy except the electrode the surface. After removing the template, the drug metronidazole from the surface of the polymer network, some channel was created to the that. So prophy ions would be through the cavity of the transfer only the electrode surface. As his response, he shows the sky blue color. Then the rebinding of the metronidazole was performed and his response is also the blue color. Figure 3B shows the impedance result of modify the electrode. The semicircle is high frequency corresponding of the electron transfer the resistance is can be seen that the small semicircles obtained as the badge C indicating the small interface resistance modified with the nano porous nickel cased the no semicircle due to the high conductivity. When the molecularly imprinted polymer was electrode deposition, the impedance value is the increased due to the non-conducting nature of the molecular imprinted the polymer. However, after the remove the metronidazole, charge transfer the resistance value is decreased. Is the successfully formation of the porous due to the extraction of the metronidazole. At the last, remaining the metronidazole with the molecularly imprinted the polymer which the non-porous nickel GC electrode is upward the change of the impedance values which could be the occupied of the part of the impedance set of the metronidazole. Figure A shows the calibrate curves of the current response with the metronidazole the concentration when is a figure shows the cyclic bertomogram of the increase the concentration of the metronidazole. Double linearity can be P current or the probability to the concentration of the metronidazole at the detection limit of found at the 0.2 femtomole. Figure B shows the selective
Okay,
test
I see
result.
the time is close, so go to the conclusions. Okay.
Okay.
Yeah, go to the conclusion. Let me see the conclusion. Okay,
The
go
3D
ahead. Yeah.
nanoporous nickel framework provide an enlonger highly conductivity surface area and easier diffusion of the electron transfer. Selective is coordinated by the specific identification ability of the electropolymerization of the molecularly imprinted the polymer. This facial electrochemical deposition method and cost effectiveness benefit is the probability. Above all, the synergetic static coupling.
Okay, good enough. Kersika, let me ask you one question. Go to the page 6, okay? Page 6. Page 6. Yeah. The topics of this paper is molecular imprint, right? But if you take a look, the scale is 1 micron. 1 micron, the hole, the dark side of the hole, it's submicron. It's much larger than a molecular print, molecular level. So how to explain that?
No, Professor. Author is did not mention in the information in this article.
Yeah, I mentioned that back to your previous slide, okay? The molecular print. Yeah, the molecular print basically it's the previous one, okay? The previous one. Yeah, basically it's a molecular size, right? So you get rid of remove the template. So but looks to me the template, the cavity is larger than the molecular size. Is that normal or is that why? Can you explain that?
No, Professor.
So basically the cavity should be in molecular level.
Because
But
author is reporter selective classify the molecular imprinted polymers and sensitive enhance classify the nanoporous nickel.
okay, so back to your page 6 or page 5. Oh, okay, this one, page 5. So basically this copper in nickel, the size is much more than molecular size. Is that right?
Yes.
So it's basically it's some micron level. Molecular size is it's below nano. So basically there's some difference. So that's why I don't know why the SEM picture say it's a molecular imprint. That's my question. But anyway, it's an interesting topics. Okay, good enough. Okay. So we go to the next one. Kumar. Kumar. Are you here? Kumar?
Yes, Professor.
Yes, go ahead. present your work.
Okay. Kitty.
Yeah.
Stop pressing. Is is visible?
Yeah. On the fourth screen. Okay. Yeah. Kumar, you need to expand to the fourth screen.
Yeah, Professor. Visible, Professor?
I can see your PowerPoint, but you need to expand to the fourth screen. Is that okay?
Okay, Professor.
To expand that to the full screen, that's it.秦进，
老师那有好
还没有，我才到一半，是在这里嘛？对，你就把这个按掉就好了，就把这个按掉就好了。
不是在这里，
这个
对，
这个按掉就好了。
点进去，
点进去以后，然后按
那个，
好，那没关系，因为我现在才一半而已。好，就这样，可以。
借我看一下，
可以吗？可以。You still not full screen, but doesn't matter. Just go ahead to present your work, okay?
Okay, Professor.
Yes. 可以了，就这样。我到时候再把这个再暂停掉。Yeah, go ahead. Yeah, good enough. Yeah.
Good afternoon, everyone. Today I'll discuss about the paper of synthesis of polyphenylene ether. With controlled molecular weight, we are suspension polymerization catalyzed by amine copper 1 catalyst using the under various reaction and condition. Introduction about this polymer. The polyphenylene ether is one of the most excellent heat resistant polymer and also is a good mechanical properties and also is low moisture absorption. Some blending polymers are using some electronics or household electronics. Mainly is currently is usually the 5G materials for blending of PP polymer. It is an apparatus setups of synthesis of PP, and this measure the volume of oxygen is consumed during the PP synthesis or perform the closed system. The volumes of consumed every 5 minutes. It is a material required for the synthesis of PP. It's a different like material like copper chloride and 2,6 dimethyl phenol and sulfate, morphine and 1-methyl imidazole and the 2,6 trimethyl phenol. Like TMP is 98%. It is a synthetic mechanism of the PP. It is using the copper N ligand catalyst is using the different type of product is there is only like major and the minus. Major product is the polyphenylene ether and is the minor product is the 3,5 dimethyl 4 oxa and the 2,5 side is called the diphenocanones. In this mechanism is the oxidative polymerization of DMP is selectively studied. This been suggests the oxidative polymerization of mechanism involves a radical or ionic reaction using this mechanism. It is a synthetic procedure of prepare of PPE. It is main importance of molecular weight control of PP. It is using 2 or 4 molar ratio. Use the DMP are added in the experimental condition. Like different ratio aqueous or organic phase ratio like 1:1, and the DMP catalyst ratio is 7:1, and ligand catalyst mole ratio is 7:1, and the base catalyst ratio is 15:1. Is all condition are using the MCR concentration of 2 weight percentage of system. And the synthetic process mainly is described for poly phenylene ether is the main focus. It's a result and discussion part. It is in all the polymerization reacts were run at the emulsifier concentration of 2 weight percentage, and the oxygen flow rate 50 cc at 20 degrees Celsius for 1 hour. And this experimental is variable the mole ratio of DMP catalyst and ligand catalyst and other emulsifier concentration catalyst, and the base catalyst are given the different type of table. It's in the table 1 shows the effect of monomer and the catalyst molar ratio on the polymerization. Whereas it is the molar ratio were varied in the range of 7 and 7:1 and 20:1 ratio. As a catalyst concentration increased both the molecular weight and yield the catalyst concentration increases both the molecular weight and also the PPR yield is also increases. This table 2 is the copper compound combined with the amino ligand have been used the catalyst system for the synthesis of PPE. The effect of ligand like DBA is like N, N dimethyl ethylene diamine are used the ratio of formalization to evaluate the result in this table for figure 2. The yield and the molecular weight as the PPE were strongly influenced with the ligand and catalyst mole ratio, like the highest molecular weight PPU synthesis in the 7. It's a DBA and the CU ratio is 7 is the highest yielding there. And next, the table 3 is the effect of base concentration of the polymerization. Is have been the result are the ligand and the catalyst are also the mole ratio is 7 is very good yield, and the table clearly shows the base cases is a low molecular weight and also low yield, low amount of yield. In this the table 4 is the polymerization reacts were carried out with the with and without STS. STS means the sulfate. When the polymerization has carried out in the absence of surfactant, and absence of surfactant is there, the lowest molecular weight observed. The absence of is the lower molecular weight is observed. It is the characterization part of PPE. It is the proton enamel. Here it is, it shows the aromatic and the methyl proton is shows. In the aromatic proton is shows in the 6.47, and the methyl proton shows the 2.30. It is the FTR spectrum. It is different absorption bands is shown, and the OH bands are 3,350, and the carbon band shows in the 2,950, and the carbon hydrogen bands is showed 1,150. And it in this figure shows the TGA and DSC thermograms are shown this figure. And the thermocomposition temperatures, the TGA is 438 degrees Celsius, and also the glass temperature is shown in the 219 degrees Celsius. Next one, the amine ligand efficiency. In the amine ligand efficiency, in this figure, efficiency of copper 1 catalyst amine complex, copper 1 amine complex catalyst system varies amine ligands such a different like DPEDA and predine and melanin and morphalin. In the oxygen uptake and measurement were performed every 5 minutes, for 1 hour. In this data are flattered in this figure. And this table 5 is even the predin showed good reactivity. The predin shows the good reactivity, and also copper chloride ligand complex system is solution polymerization, and predin morpholins are not proper ligand our heterogeneous system. Next we and the control the control of PPS with the molecular weight, and this in the scheme references the addition of mono functional reagent is the TMP, and the TMP is an para portion with the OH para portion of the OH group, and also the block the methyl group. So it is the way to control the molecular weight. The reaction are performed without addition of TMP, and with addition of TMP. Without addition of TMP is 0, and with addition of TMP is 2 weight percentage and 4 weight percentage. In the table is clearly shows the molecular weight is very much dependent among the TMP added the possible the control of molecular weight of PPE. As a conclusion, this paper is oxidative polymerization of DMP was carried out the using CuCl amine complex initiating the system via water chloroform biobasic suspension polymerization. Various ligand were employed. They evaluated the ligand efficiency by measuring the volume, the oxygen uptaken with DBEDA with used the highest oxygen uptaken observed like a MAME. However, they found the B to the most efficient ligand that terms the molecular weight. In order to control the molecular weight PPE, TMC is added the polymerization recipes, and it's
Okay, good enough. Can you go to the first page? The first page, it's I just want to know, PPE is a very useful material, but not very new material. So what kind of paper is okay? 2012, okay. So 2012, it's almost 10 years ago. So no wonder it's so what kind of paper is this paper? Can you show what kind of paper? The journal name of this paper?
speak, Professor.
The journal title of this paper? PPE is good. Okay, I mentioned to you guys in the class. I think this synthesis method to review that is very good. Okay, but I think the journal is a little bit old. Okay, but it doesn't matter. I just want to know which journal you
Wait, Professor. I'll
got
show.
this paper from. Okay,
It's not open, Professor.
it's not open.
Yeah, Professor.
Okay. One more question is PPE is very good chemical resistance. So what kind of solvent they use to dissolve this PPE? Do you know?
No, Professor.
No, they mentioned that. They mentioned that when you do the intrinsic viscosity, I think they use chloroform. Do you do you notice they use chloroform to do that? Yeah, chloroform. I think it's a good mechanical chemical resistant. Yeah, they use chloroform. Yeah. Okay, good enough. Okay, Srinisi. Okay, your turn. Srinisi.
Is that
Yes,
yes, Professor?
go ahead.
PPT in there. Open PPT was open.
Is it audible, Professor?
Yeah,
Can you see in my PPT?
I can see your screen, but you need to get to the full screen. Yeah.
Yeah. Is that okay, Professor?
Not improved. It's still not in the full screen. If you cannot, you know the right hand side. Yeah. This no yes. Go ahead. Yes.
Yeah, okay, Professor.
Yes.
Now I'm going to present improvement in mechanical and thermal properties of polypropylene nanocomposite using an extremely small amount of alkyl chain grafted hexagonal boron nitride nanoseeds. So in this study, hexagonal boron nitride nanoseeds grafted with aliphatic group were prepared by sonication alcohydrolysis reaction using hexagonal boron nitride with 1-dodecanol and polypropanil nanocomposite. And these nanocomposites were improved mechanical and thermal properties, then addition of HBN. Okay, so in this, therefore, the polymer composite containing thermally conductive fillers like metallic particles, ceramic powders, and carbon materials have been synthesized, overcoming the weak disadvantages. So, in particular, carbon nanomaterials like carbon nanotubes and graphene-based materials have been used to scrutinized for the effective nanofiller materials for polymer composite due to their higher thermal conductivity and mechanical strength and tensile strength. So this is a preparation of poly nanocomposite for however, the use of these highly thermal conductivity fillers for the polymer composite in the electronic packaging and encapsulation applications required electrically insulating properties can be limited. So, because of their higher electronic conductivity. So, in this paper, they used a hexagonal boron nitrate with a polypropylene compound. So, this is a preparation method and they are prepared polymer composite
哎，请陪正，请那个家福赶快过来一下，我这边上课断掉啊。
老师，老师，
你快点帮我弄，我断掉，我怎么
断掉？
对啊。
centimeter inverse in the spectra of alkyl BN can be assigned to the CH stretches of methylene and methyl groups It suggests that alkyl chain was successfully functionalized
那
on
现在还是
the
有在录吗？
surface of alkyl boron
有在录
nitrate.
吗？
So the
刚
BO
刚
stretching,
断掉的时候没有
BOC stretching, out of
刚刚
plane
断掉
OBO
没录到。
bending, and
OK
in plane bending vibration modes
OK
respectively
OK，
they have
好
been
好，可以，谢谢。
demonstrated. So this is a XPS analysis performed to investigate the chemical state of elements and their ratio. Shows the XPS. So it shows this XPX spectra of HBN and alkyl BN respectively. So the B1 is a spectra of a pristine HBN are 2 peaks. This corresponding
OK，
to the
Srinisi，
Professor.
it's time is close, so go to the conclusion. OK.
Okay. So this is the mechanical properties.
Yes. OK, go ahead.
Okay. Okay, Professor. This is the mechanical properties of synthesized of a poly nanocomposite. This tensile strength decreases from 31 megapascal to 29 megapascal by increasing the content of HB and different composite. So other hand, the tensile strength with a nanocomposite shows the maximum value when the filler content is 0.1 weight percentage, while it is slightly decreases from 32 to 30.6 megapascal when the filler contents increases. So although the maximum tensile strength value was obtained when the content of alkyl boron nitrate. So in the study, the optimum alkyl boron nitrate content to give maximum mechanical strength might can be smaller than 0.1 weight percentage. So this is the thermal properties. The thermal stability of polypropylene nanocomposite is improved by thermally stable HBN based filler. The residual weight of the preferred polycomposite are much larger than that of polypropylene. When the HBN increases the specified weight percentage, then isothermal treatment increases. When the content of alkyl composite shows in the different percentage respectively. So again, the poly nanocomposite show larger residual weight than the first polypropylene compound at the same concentration of filler due to the enhanced.
Trinity, the time is conclusion.
Okay,
Yeah, go ahead. Yeah.
So finally, we concluded that the composite containing the young modulus increased by the 17.5% compared to that of polypropylene without any sacrificing the tensile strength. So thermal conductivity of the preferred nanocomposite improving when adding the alkyl boron nitrate.
You know, my first question is BN, HBN. Do you know what's the purpose to add that material into the polypropylene? What's the material? Yeah, what's the purpose to add in this material? To add this material, do you have any idea?
They are prepared by this the HBN when treated with dodecanol when the ethanol Professor.
Well, I think it's barium nitrile. It's very good for thermal conductivity. Do you know?
Is
It's
Professor.
probably the most
More
good,
conductive.
the best thermal conductivity material ceramic in the world. So basically, they add that material into polypropylene, try to improve the thermal conductivity of polypropylene. Do you know? I
Yes,
think that's
Professor.
the main purpose for this paper. Of course, they will increase the mechanical properties, but I think the main purpose is for increase the thermal conductivity. That's it. Okay, good.
Yes, Professor.
Okay, so the next one is Ruspika. Go ahead, Ruspika. Ruspika, is that yeah. Ruspika, I think you have some audio problem. We have some audio problem. You need to change either your computer or your mobile phone and everybody
Hello?
except you will close the microphone. Okay? Yeah, go ahead. Everybody besides you will close the microphone. That's good for you because I think the audio will have some noise. Okay, okay, okay. Go ahead to present your work, please.
Okay, please. Okay. Good evening to all, and let me. My topic is a metal organic
No,
framework
no, no, no,
and
no, no, no,
conducting.
no. You need to show me your screen PowerPoint first. Okay, you need to show me your PowerPoint first. Okay.
Professor, can you see me? Can you see the PowerPoint?
So far, no, I cannot see. Yes, yes, yes. Good, good, good. Yes. Go ahead. Yes.
Okay, Professor. Good evening to all. I'm going to present on a metal organic framework and conducting polymer-based electrochemical sensor for high-performance cadmium ion detection, and it's abstract. And in this conductive electrochemical sensor, which was UIO 66 NH2 at PNI, which is a polyaniline, was successfully prepared by polymerization of conducting polyaniline polymer around the metal organic framework, and it was synthesized via hydrothermal method. And then the resultant material was constructed for electrochemical sensor for detection of cadmium ions. And the method of coating metal organic frameworks shows a utility for constructing highly sensitive electrochemical sensor for detecting the heavy metal ions and more. An introduction. And in this recent year, the release of harmful heavy metal ions into the environment has attracted great attention worldwide because of their toxicity and widespread use. The cadmium is among the most of the toxic heavy metals, even at low concentration, causing a large number of health issues. And due to its high toxicity and bioaccumulation factor in the food chain, the development of sensitive methods for determination of cadmium ions at trace concentration is of importance, and several analytical methods have been based on mesophorous materials, and electrochemical stepping voltammetry have been recognized as a selective and sensitive technique for the detection of heavy metal ions because it involves an effective pre-concentration step with advanced electrochemical method for the accumulated analytes. And in this past decades, the metal organic framework with high surface areas, uniform pores, and chemical tunability and the characteristics makes the MOF unique material with the potential for diverse application. The several conducting polymers and a variety of application in sensing technology exhibit interesting electrical properties. And polyaniline is one of the most promising conducting material due to its ease of preparation and high conductivity and good stability in the presence of water. The preparation of polyaniline with other materials to form solid composites have been subjects of considerable research interest. And in this work, the MOFET polyaniline composite material was prepared by loading PNA on the surface of the MOF, and the synthesis of UiO 66 NH2 in this zirconium chloride and amino ammonium benzene dicarboxylate were dissolved in DMF, and it is ultrasonicated for 30 minutes, and it is transferred into Teflon and autoclaved at 120 degrees Celsius for 48 hours. And in the synthesis of UiO 66 NH2 at polyaniline, it was dispersed in hydrochloric acid, and aniline was added to the mixture and sonicated for 20 minutes. And in this, the APS solution in hydrochloric acid was added dropwise the mixture was stirred overnight and to get a complete polymerization. The resultant precipitate was centrifuged and rinsed 3 times, and it is and washed with double distilled water and alcohol. And this is the XRD pattern of polyaniline, and for polyaniline we got two broad peaks at 20 and 25 degree, and which represent at 100 and 110. And for UiO66NH2, it matches the XRD pattern, matches the calculated XRD pattern, which the final composite which displays the similar XRD pattern of UiO66NH2 with the slight difference in the peak intensity. And this is the SEM images, SEM and TEM images of UiO66NH2, and it is shown that the more regular facet surfaces than the UiO66NH2 PNA, both of them have a discernible and better dispersion, and it can facilitate the formation of the robust homogeneous film for the construction of an electrochemical sensor. The TEM images confirms the octahedral cubic intergrown crystals, and which is clearly reveals that the core shell morphology of the composite. And this is the XPS of XPS, and in this the nitrogen spectrum of UiO66NH2, the peak at 399.4 and was assigned to NH2, and the other peak at 400.8, which is due to the interaction between the amidogen and peak at 28.3, 399.3, and 400.5 and 401.9, which shows the spectrum of UiO 66NH2 at PNI, which corresponds to the neutral and imine like and neutral and amine like nitrogen atom, and protonated imine and ammonia and protonated amine units. And this is the TGA of TGA curve, and the first weight loss was ascribed to the release of moisture and bound water from 50 to 150 degrees Celsius, and in the second step the weight loss at 150 to 304 degrees Celsius, and which is due to the dehydroxylation of OH and was complete. And in the third step the weight loss was due to the decomposition of the material at 621 degrees Celsius. And as from UiO66NH2 PNA, it was seen that the sharp weight loss begins at 121 degrees Celsius, and it continues till 621 degrees Celsius, and which is probably attributed to the large scale thermal degradation of polyaniline chains. And the weight loss percent of polyaniline is 19.4%. And this is the scan rate of scan rate, in which as the peak current increases and the current also increases. In this shows the diffusion controlled mass transfer process. And this is the reversible redox peaks, which was obtained at batch GC, and the relative larger anodic and cathodic peak current was observed, which can be due to the large specific area and better conductivity. And the CV response shows that the larger current signal, and indicating that the corporation of polyaniline and the composite, which accelerate the electron transfer and enhances the electrochemical sensitivity. And EAS, which provides the information about the interface properties and impedance changes in the process of electrode modification. And the batch GC has a relatively large electron transfer resistance at of about 246 246 coulomb, and for PNA polyaniline coated on the surface of the MOS shows 76 coulomb, and which indicates the polyaniline has a electrical conductivity, can accelerate the electron transfer on the electrode. And this is the electrochemical response was investigated using the DPV, and the small oxidation peak was observed at batch GC. And when the UiO66NH2 was coated on the electrode surface, the oxidation peak current increased significantly, and the oxidation peak current was larger than those of the two electrodes before. And this is because the polyaniline can increase the conduction pathway and promote the electron transfer between the solution and the electrode surface. And the UiO66NH2 at PNA, and which modified GC, shows the well-defined peaks and almost tenfold current increases response to the cadmium ion, which is credited to the synergetic effect of the composite and the composite with the polyaniline. And this is the DPV curves at different concentration. And these are the comparison table for different electrodes for the determination of cadmium for the in the other modified electrodes. And this is the determination of the feasibility of the proposed sensor was validated by analyzing cadmium in lake water, tap water, saliva, and urine, which is showed in this table, and which shows the recoveries at 97 to 103 percentage. In conclusion, and the composite was successfully prepared via hydrothermal, and the prepared composite made modified, which is applied for the detection of cadmium ions by DPV, and compared with the cadmium ion sensor, which shows the lower LOD at 0.3, and with wider linear range and better stability and reproducibility. And the practical application was demonstrated by the determination of cadmium ions in real sample. And all of these features suggested that our conducting material coated MOF will lead to an exciting existing future and intriguing discoveries of MOF based electrochemical sensor for environmental monitoring and clinical diagnosis. And besides, a high selective functional group should be developed to improve the selectivity of the material for the analysis targets and analytes in a complicated matrix.
Okay, looks good. Okay, let me ask you. So, do you know what kind of MOF, metal organic frame, uh, is porous material? But do you have any details about MOF, for the polyaniline? Can you show us?
Uh,
Ruspika, yeah,
uh,
yeah.
uh, yeah, Professor. But it has a high surface area and uniform force and chemical tunability.
Yeah, but MOF meaning it's a 3D
Metal
structure.
organic form.
Yeah, it's a structure, so you have a more surface area, so that's why you can be a good sensor. But I just want to know what kind of MOF, what kind of structure they propose they propose inside. Do you have any idea? I I
Actually,
cannot
it
I cannot see your screen. Can you share your screen? Okay. Ruspika, never mind. Okay.
yeah. Okay.
uh, just we go to next one. Kumar 2. Okay, Kumar 2. Are you here?
Professor.
Yeah, go ahead. Share your paper, okay?
Are you visible?
Yes. Where is your I think I need you need to expand this to be a full screen, okay?
Okay.
Kumar, where are you?
Yes, Professor. It is visible.
I can see your screen, but you need to be a full screen first. Then, yeah, go ahead. Yeah.
Okay, good evening to one and all gathered here. I am here to present a paper entitled High Glass Transition and the Thermal Stability of the New Pyridine Containing Polyimides and Effect of Protonation on the Fluorescence. This paper mainly aims to prepare the monomer and the polymer of polyimides and characterized by the instrumentational studies like proton NMR, carbon 13 NMR, and elemental analysis and differential scanning calorimetry. Why it's not good?
Yes, you need to be on the broadcast
The
the
page is
screen. Okay, the screen now is not moved.
I don't know why it's not.
Mura, please change the reading mode.
Hmm?
Reading mode. Reading mode போடு. Slide show பக்கம் இருக்குல்ல அதை போடு.
எங்க?
இங்க கீழே ஸ்லைட் ஷோ இருக்குல்ல அதுக்கு பக்கம் ஒரு ரீடிங் மோட் இருக்கும் அதை போடு அப்பதான் சேஞ்ச் ஆகும்.
Yeah, you need to go to the reading mode. Yeah, good.
இதுல ஓப்பன் ஆக மாட்டேங்குதே.
ரீடிங் மோட் போடா. ஓப்பன் ஸ்லைட்ல இருக்குல்ல ஸ்லைட்ல போய் ரீடிங் மோட் கொடு.
Okay, sorry for the disturbance. The introduction, the main aim is to prepare the monomer and the polymer and characterized by the instrumentational studies. And they have discussed the different chemical properties of the polymer. The slide shows the synthesis of the monomer. They have different steps. This full steps are the step 4 have been named as Chichibabin amination reaction.
Kumar,
When I go to the next slide.
Kumar, you need
Yes,
to.
Professor.
Kumar, stop. You need to go to the full screen. Yeah, you need to go to the full screen.
Kumar,
Yeah. Yes. Then you can control by yourself. You need to go to the full screen, okay? Expand to the full screen.
போடுறா கொடுத்துட்டு ரீடிங் மோட் போ. ஸ்லைடு போ.
Yeah, the reading mode. Yeah, the reading mode, but need to be the full screen. Yeah. Now in the PowerPoint, it's not the full screen. Kumar, is that okay? I cannot read your material so far.
I think I have a problem with that.
Kumar, you prepare that. Let's go to the next one. Vacency. Vacency.
Yes, Professor.
Yeah, okay, go ahead. Yeah.
Okay, Professor.
Vacancy, are you ready?
Yes, Professor, I'm ready.
Yes, go ahead.
Professor, can you able to?
Yeah, I can read that. Go to
Yes,
the
Professor.
full screen. Expand to the full
Yes,
screen. Yeah.
Professor. Just a minute, Professor. Professor, can you see my full screen?
Not at this moment. No, not at this moment. You need to
Professor, now?
no, no, no.
No, Professor.
No, but doesn't matter. You go ahead to present your work. You control by yourself, okay? Otherwise, okay, go ahead.
Ignore. Vasandan, please change the reading mode. The light show பக்கம் இருக்கு பாருங்க அதை கொடுங்க. இதை மேக்ஸிமைஸ் கொடு. மேக்ஸிமைஸ் கொடுத்துட்டு அங்கே போ. இல்லை மேக்ஸிமைஸ் பண்ணிட்டு அங்கே போ.
So,
Professor, can I start to present now?
you can go ahead. Just
Is
use
it
this
okay?
mode to present your work. Doesn't matter, okay?
Okay, Professor. Good evening, everyone. I'm going to present a review paper on nano fibrillated cellulose using PAM electrolyte based on flexible and sewable high performance ZnMnO2 battery with superior shear resistance. And the impact factor of the paper is around 11.459, and it is published in Nano Micro Small Journal, and by corresponding Professor Chun Yu Zi from Hong Kong University. And this is the outline of the presentation, which I'm going to see about experimental part, result discussion, and conclusion. And the introduction is about there is utmost need for flexible and variable energy devices, but enhancing the tolerance to various mechanical stress is the key issue. And however, the shear force is inevitably applied on the batteries during the stretching, bending, and twisting. Herein, a sewable zinc MnO2 battery based on a nano fibrillated cellulose with polyacrylamide hydrogel electrode deposited over zinc nanoplates as anode and carbon nanotube MnO2 as cathode is reported. As you can see from the image, carbon cloud is used as a substrate in cathode, and NFC PAM hydrogel is used as a solid electrolyte, flexible solid electrolyte, which is deposited on and over the cathode anode material, which is zinc nanosheet. So this is a need for going for flexible solid electrolyte, as the conventional lithium-ion batteries have the drawbacks of liquid leakage, toxicity, and ignitability. So to avoid those disadvantages, we go for flexible solid electrolyte. This is the experimental synthesis of PAM electrolyte, NFC PAM electrolyte, in which acrylamide is used. Acrylamide monomer is used along with potassium persulfide, which is dissolved in cellulose dispersion for about 30 minutes, and it is stirred, and then the N-methylene bis acrylamide of 2 mg is added, which is stood for about half an hour, and then it is transferred to the glass substrate, and the glass substrate is heated of about to about 60 degrees Celsius, where the polymerization takes place. As you can see from the image, the cellulose nanofibril is doesn't have the pores initially, but after the polymerization, it has the acrylamide embedded on its in its pores, so which clearly states the polymerization. So this is the electrochemical analysis in which the EAS data shows the high conductivity of NFC PAM when compared to the conventional PAM. The conventional PAM is fabricated using deionized water in order to compare the data between the nanocellulose PAM and the FTR data. In the ES data, it is clearly seen that the NFC PAM has the high conductivity of about 22.8 Siemens per centimeter when compared to the conventional PAM, which is about 16.9 Siemens per centimeter. The FTR data shows that the typical band for amide groups of PAM and CO11 groups of NFC overlap, and it has a sharp absorption peak at 161 centimeter and at 1620 centimeters, and also as you can clearly see that at the transmittance of the NFC PAM, which is shown in NFC, which is shown as green, and the NFC PAM, which is shown as red, at the transmittance of 3434 and 3425, which is overlapping with an NFC PAM, which shows the NFC PAM has the both OH bond and carbon bond. And the cyclic performance of NFC PAM is around 88.3%, which is high over even over the 1000 cycles. This data is compared between the conventional aqueous electrolyte batteries of ZnMO2, and this is the stress strain analysis which is reported in the paper, in which the pure PAM possesses a relatively small strength of only 38 kilopascal. In the contrast, with the addition of NFC, the strength can be enhanced to 158 kilopascal, which is 4 times to that of pristine PAM, which is about has a large strain of 1100 percentage. So, along with the stress, shear force is applied to the battery. Shear force test is also given to the battery fabricated battery by sewing it with a machine in which the data have been more. The data shows that it has high capacity. The batteries which is sewed has high capacity, and this is some analysis of the reported battery, in which the figure 1, which shows the NFC, and figure 2, the PAM, and in which the NFC PAM layer has more pores than compared to the ordinary PAM layer, in which the pore size has been increased to about 100 micrometers, as you can see from the same images. And resultant discussion, a PAM formed in the frame of cellulose network through a free radical polymerization with N-methylene bis acrylamide as the cross linker. This the NFC itself can easily form a 3D network with large space promoted by the length of 1 to 5 micrometer and interacting entanglements in addition with the hydrogen bonds. So for a comparison, a pure PAM hydrogel was prepared by replacing the cellulose dispersion with deionized water, as I mentioned before. And this in this paper, the hydrogel NFC polymer acts as a support of pore wall and acts as an expander for pore size due to its high water absorbency, as we seen from the SEM images. Uh, Thus, the incorporation of NFC into PAM created a large porous structure and improved mechanical properties. And the SUD ZLMO2 battery retains 88.5% of its capacity after 120 stitches with withstands high large shear force of 43 Newton. The NFC also stabilized the channels and enlarged pore size for electrolyte ions, and thus a high conductivity of 22.8 ms, microsiemens per centimeter was obtained.
Okay, let me ask you, for battery, what's the electron capacities for this battery? Do they report any of that?
Uh, they have not reported about the capacities.
Oh, it's too small. Its capacity is too small. It's a meter. Meter.
Yes, yes, professor.
Can you enlarge that? It's a meter. Meter ampere, right? Meter.
It, Actually, it is a meter Siemens per centimeter, professor.
Meter Siemens. So it's very, very small, huh?
Yes, professor.
For
Yes.
battery. Okay, so
The thing is, they have made a toy using this stitching technique along with the battery, professor.
yeah, but the
So
battery they use this for what? For cathode
wearable
or
clocks.
for anode or for the membrane, the between these two nodes. What's the hydrogel for? Yeah. Go to page 5. Page 5. Let me
Page
see.
5.
Page 5. Yeah. Let me see what's flexible solid state electrolyte. So basically, they use then as an electrolyte, right?
Yes, professor. Yes, professor.
Okay. Yeah, that makes sense. Electrolyte. Okay. But very, very small amount of electric currents. Okay, good.
Yes,
So
yes, professor.
now we go to Kumar. Are you okay?
Yes, Professor.
Are you okay now?
Yes, Professor. I will share.
Yeah, go ahead. Present your work. Yeah, go ahead.
Okay. Sorry for the inconvenience, Professor. Good evening to one and all gathered here. I am here to present a paper entitled High Glass Transition and the Thermal Stability of the New Pyridine Containing Polymers and the Effect of Protonation on the Fluorescence. Um,
Where are you, Kumar? I lost you.
okay.
Yeah,
This
go
paper
ahead.
mainly aim to prepare the monomer and the polymer of the polyimide and characterized by the proton NMR, C13 NMR, and elemental analysis and differential scanning calorimetry. They have discussed the different chemical properties of the polymer. This slide shows the monomer synthesis. They have different steps. This completely called the Chichibabin amination reaction. This slide shows the polymerization reaction that have tried with different substituents in the AR position and elucidate the properties.
This slide shows the characterization of the monomer by the proton NMR. The figure A shows the proton NMR of the monomer, which have the 9 different protons in it, and the figure B shows the carbon 13 NMR for the monomer, and the FTIR spectra shows the peak at 3440 and the 3361 centimeter inverse that shows the presence of amine group, and they also confirms the monomer's melting point as 255 degrees Celsius by the differential scanning calorimetry. And the slide shows the FTIR spectra of the polymer for the different substituents at the AR positions. The peaks around 1780 and 1720 centimeter inverse that shows the asymmetric and symmetric structures of the carbonyl group of imide, and the 1370 centimeter peak is due to the formation of the amine group. Okay, then this slide shows they have discussed the different properties, like now I have thermal properties were evaluated by the differential scanning calorimetry and the thermogravimetric analysis, and comparatively the different substituents, the 4D and the 4E as the substituents have the higher melting point. I give a short note on differential scanning calorimetry. It is a thermoanalytical technique in which different amount of heat required to increase the temperature of the sample. Figure B shows the differential scanning calorimeter, and the figure A is the inner area which the compound should be placed and then analyzed. The mechanical property of the polymer have been elucidated here. Comparatively, the 4A and the 4B should be very flexible than others. And this is the electrochemical property of the polymer. This diagram shows the reduction values at minus 0.66 and minus 1.65 volt, and the oxidation peaks at 1.20 and the 2.34 volt. This shows the good acid sensor. And finally, I go to the conclusion. The paper has successfully synthesized the high thermal stability polymer, and the solubility were checked by the different solvents, and they have showed the different chemical properties, and promising that the polymer material is having high TG value and good for acid sensor and optoelectronic application. Thank you.
Kumar, you know, your paper you search for is too old. It's 2008. So,
yes.
But it's good material, polyimide. Let me ask you one question. What's the polyimide used for at current times? What's polyimide most application in what kind of area? Do you know?
Polyimide.
Yeah. Polyimide. Used for what? What
It's
kind
used
of?
for the many purpose like time temperature indicator, and the thermal that have a good thermal stability. That's why they have used.
You know, a very, very big area for polyimide now is for, do you know the PCB? PCB board, electronic board. They use for flexible electronic board. You know, the yellow one, the flexible electronic board. So basically, it's a very useful material. DuPont has one sample they call Capton, Kapton. It's made of by polyimide. Okay, very useful material, but the information is a little bit old. Okay, that's good enough. Okay, so we go to the final student is Evangeline. Are you
Yes,
here?
Professor.
Yes, go
Professor.
ahead. Yeah, present your work.
Is my screen visible, Professor?
Yes, good enough. Go ahead.
Good evening, Professor and everyone. Today I'm going to present the paper entitled Mechanical Properties Developing at the Interface of Amorphous Miscible Polymers Below the Glass Transition Temperature time-temperature superposition. The main objective of the article is the bonding of amorphous polystyrene and PPO was conducted over a broad range of time and temperature, but below the glass transition temperature. The stress-strain properties developed at the symmetric and asymmetric interfaces was measured at the room temperature as a function of contact time and bonding temperature. Master curves of shear strength and modulus were constructed, and the Arrhenius apparent's activation energies was calculated for shear strength are given. The experimental procedure. The preparation of the samples is the films of PS and PPO of about 100 micrometer in thickness were prepared using a twin screw laboratory extruder with smooth calendering rolls. The temperature was 225 degrees Celsius for PS and 286 degrees Celsius for PPO. No deformation field was applied to the extruders. Now the welding step. The contact pressure was 0.8 MPa and the contact time varied from 2 minutes to 96 hours. The bonding temperature ranges of 55 to 90 degrees Celsius for PS-PS interface, 113 to 156 degrees Celsius for PPO-PPO interface, and 70 degree to 100 degrees Celsius for PS-PPO interfaces. A limited number of PS films of 140 micrometer in thickness were also used for bonding the PS-PS interface at 90 degrees Celsius for 24 and 96 hours. Now to the resultant discussion. Here are the data for the shear strength of the asymmetric and symmetric blends. In the slide, we could see the two graphs. The first graph represents the shear strength developed at the PS-PS interface. The plot was plotted between the log contact time versus shear strength. In that, we could see as the temperature increases, the shear strength also increases from 55 degrees Celsius to 90 degrees Celsius. Here the second graph represents the master curve of 70 degrees Celsius, which is the reference temperature chosen. With the help of the second graph, and the Arrhenius plot is also given, and the enthalpy of the blend was calculated as 99 kilocalorie per mole with the help of Arrhenius equation. And next, the shear modulus developed at the PS-PS interface was given. The first plot represents the log contact time versus the shear modulus. It shows, in contrary to the previous graph, it shows a very small increase in shear modulus with a increase in temperature. And the master curve of 70 degrees Celsius was chosen as the reference temperature. With the help of the second graph, the Arrhenius plot is also plotted, and the enthalpy was calculated as 191 kilocalories per mole, which is twice the value of the previous one. Next, the shear strength developed at the PPO interface was given. The first graph shows the log contact time versus shear strength. Here we could see a gradual increase in shear strength when the temperature is increased, and the 136 degrees Celsius master curve was chosen for the reference temperature, and the corresponding Arrhenius plot is also given. With the help of Arrhenius equation, the enthalpy was calculated as 81 kilocalorie per mole. Next, the shear strength of PS-PPO interface is given. We know that PS-PPO blend was miscible, that is miscible over the full range of composition. Here the shear strength versus log contact time graph was given. It shows that increase in shear strength with the increase in bonding temperature. Here the master curve of 70 degrees Celsius was chosen, and with the help of the master curve, it was plotted. Shear strength versus shift factor is given. The corresponding Arrhenius plot is also shown. With the help of Arrhenius equation, the enthalpy was calculated as 144 kilocalorie per mole. The enthalpy of this blend was greater than that of the previous ones. This is because the diffusion of PS chain is less mobile. Uh, in less mobile PPO surface requires more energy than the diffusion of PS chain in more mobile PS surface. Thus, we could see the reasonable increase in the enthalpy value. Now, the conclusion, it has been shown that the shear strength and the shear modulus developing at symmetric and asymmetric interfaces at low temperature with below the TG can be described by the master curves. And the higher value of 199 kilocalorie per mole was calculated for the shear modulus at the PS-PS interface, resulting that the development of strength and modulus is controlled by the development different molecular factors. That is, the modulus is controlled by the number of chains across the interface and the strength by the depth of penetration in accordance with the general mechanism of bonding proposed in the literature. That's all, Professor.
So as is I think we mentioned that in the class, okay, PS and the PPO, okay. Can you explain just one sentence why PS and the PPO are compatible? Do you have any idea? Do you have the structure of PPO and the PS? Chemical structure. Can you show us the chemical structure? Do you have that in the literature?
No, Professor.
So can you explain to us why the PS and the PPO are very compatible? So PS can let PPO process very easily to improve the processabilities. Why? Do you have any idea?
The diffusion of PS chain is PS chain in less mobile PPO surface.
Yeah. But why? In chemical point of view, you know, the PS, they have a benzene ring, right?
Yes, Professor.
And the PPO, they also have benzene ring, right?
Yes, Professor.
Benzene PPO is in the main chain and the PS is in the side chain. But because of the benzene is very compatible for each other, so that's why PS can make the PPO process very easily. Do you know? So that's why they calculate the we call the activation energy. See, they decrease the energy or not, right? So basically, that's the main purpose of this paper, right?
Okay.
Yeah. So it's interesting paper. Okay. So we finish our work. Okay, we finish our presentation. That means our class is over. Okay, our class is end. We have a normal class, but you know, you need to register for the qualified exam, right? I have no idea how to make the qualified exam, PhD qualified exam. As soon as I know, I will let you know. Okay, I don't know they will be work on home exam or some other exam. I have no idea right now, so I will ask uh, the office. Okay, I will ask the EOMP office to see what's their decision. Oh, okay, so I will let you know in the line. Okay, in the line. Okay, for your PhD qualified exam. Is that okay? Okay,
Yes.
if that's okay, I think we just finished today. Wait for my line. Yeah, yeah. Do you have any question?
No, Professor.
No. Okay, good. So wait for my line.
Okay.
Wait for my line to see how to take your qualified exam. Okay. I have no idea so far. Okay. Good.
Okay,
Good
sir.
luck. Okay. Good luck.
Thank you.
Okay.
Thank you.
Bye bye.
Thank you.
Bye.
Bye.
Bye bye.哎，家福在吗？